In this section, we're going to discuss how functions are objects. So functions are not any different than these other objects that we've talked about: booleans, integers, floats, strings, lists, ranges, and others. So each of these objects has a type and a location in memory. Functions are the same. They have a type and location in memory. They do differ in that they are callable. That means you can put parentheses at the end of the function name and then execute the code that they reference. But otherwise, they are just like all of these other objects that we have covered. They just look a little bit different and they are new. So in this section, I'm going to call the type function and find the ID of built-in and UDF, so you can see that they're just like any other object. So we've seen this before where we can take the type of some number. We see this is an integer, this is a boolean, this is a string, and so forth. So what you can do, you can actually pass the function name over here into the type. Notice I'm not executing the function, I'm just passing the name. So we define square root above, and you can see that its type is actually function. So it's just like any other object in that respect. It has its own type, which means it does have attributes and methods, which we will see in a different video. Now, you can also do the type of a built-in function. It has a slightly different type. It does say that, in fact, it is a built-in function. The UDFs will just have a type of function, but the built-in functions will have a slightly different type. All right. Now, notice I'm not calling the function. So I'm not saying I want to get the square root. Let's say we want to get the square root of 1,000, have some initial guess and some max error. No, I'm not doing this. I'm simply placing the function name in the type function. I am not actually calling it. So there's a big difference between just referencing the function name and calling it. All right, so let's also see that each of these functions has an ID. So just some location in memory, just like every other object. Let's go again with the integers. We'll have an ID. We can put in the square root function that has some location. The built-in functions also have a location as well. So in this respect, with their type and their ID, they don't have any difference than any other object. They're just another object in Python. All right, so let's see some other things that you can do with functions. You can assign functions to a variable. So this is admittedly pretty strange, but it's no different than saying, all right, let's just say the variable A will be assigned to the integer 123, B will be assigned to some string Python, and let's just say C is now going to be assigned to the square root function. So yes, you can do this, and this looks really funny, and we'll just say D is equal to the built-in function sum, so we have all of them. So now C references that same code as the square root function. So if I press Shift Tab Tab, well, it's just a different name, but it'll just execute that same code, and we'll just find the square root again. And this time I'll just use the variable name C instead of square root. Same thing with sum. So sum, if I press Shift Tab Tab, can now be referenced as D. And this is not something you typically do, by the way. I'm just showing you that you can do this. It's just like all these other objects. And here we can just sum up a list like this, so it works the same. Next, I'm going to show how you can pass a function to a function. So this again is a little bit strange. It is something you do more frequently than just assign function names like this. So let's say we have some function we're going to call aggregate list, and it's going to take in a list. We'll just use the variable name a_list, and then some function to aggregate. So what we're going to do here is we're going to use this function. So this is going to be a function, and I'm going to use its new name now, whatever is passed in over here, and I will pass in the list over here. So this will be a list, and this will be a function. So you can think of like, okay, the func could be sum, the list could be any list of integers, and it will just return the sum of that list. Okay, so let's see how this would work. Aggregate list. And now to make it work, I'm going to just have some list over here. And then I'm going to have a function. And here I'll just use the sum function. So func will be sum. And it'll just be like sum of a list, like that. I could change this to min and find the min of the list. I can change it to max and find the max of the list. It's already sorted, so let's just change this to like this, 33, and say sorted, and it'll return the values sorted in a new list. Moving on, as I've mentioned before, functions are callable, which means you can take their reference their name and put parentheses at the end. Not all objects are callable. So, for instance, integer objects, say this 1, 2, 3, if I try to call this with open and close parentheses, it's going to say object is not callable. Okay, we cannot call an integer. All right, same with strings. Let's go ahead and make this a some string over here. And the string object is not callable. Okay, instead of testing it out and getting an error, there's actually a function called callable, and you just place your object in there and it determines whether or not the object is callable or not. So let's just test some of the other ones that we've done. So like the square root function, well, that it certainly is callable. Sum, the built-in sum function, that is callable as well. As we'll find out, there are other objects that are callable, such as classes and methods. So if we put in the constructor, now that is callable, str. You can call that. So is the int constructor. So is the range constructor. So we called all of these in that module on constructors that we went through. So callable is the way to determine whether or not your object is callable. All UDFs and built-in functions are callable. Okay, so this is just some terminology to wrap things up. So across programming languages, we say that functions are first-class objects, which means functions just behave just like any other object in Python. You can assign them to a variable, as we saw. We can pass them to a function, which we also saw. You can also return them from a function, which we didn't see, but that is a more advanced use case. But anyways, all three of these together make them first-class objects. So that is a little bit more on how functions operate just as any other object in Python.